Hopefully everyone can see my screen and everyone can hear me. Yeah, I'd like to talk about the real client projects, and particularly with a problem they solve, not only for the clients that we work with, but also for the students that come through the boot camp. But before I do, um, and again, feel free to ask any questions. Um, I'll try and get to them as I see them pop up. But before I start into that, I just wanted to take a moment to introduce myself. So my name is Alex. I'm a project manager with Beam Data. I myself am a graduate of the WeCloud Data Science Bootcamp, and my path towards a career in data science didn't come about by any of the conventional means. And the conventional means are probably more associated with, coming out of a STEM field. I did not. Maybe much like many of you, uh, I wanted to undergo a career change. My background was actually in film and television, and my educational background before that was through the history and political science at the University of Toronto. But I became sort of enamored with this growing power and currency that data was proving to be, and sort of engaging with predictive analytics was fascinating to me in terms of like its potential and what it seemed to be doing. So I began looking into it, and the further I looked into it, I found WeCloud, and then I went and completed the boot camp, and then I completed some real client projects and for Beam Data, and then they liked me enough to so that I stuck around, and here I am. Here I am at this moment. So I just also wanted to touch on something. Adam was taking you through the boot camp. I wanted to touch on what I think are two of the biggest benefits to the boot camp. One is the way it's structured, and certainly my experience with it, and I think Ricardo, who's also a graduate of the boot camp, might be able to echo my sentiments. But the curriculum is structured very well in that, yes, it absolutely acquaints you with the fundamental concepts that you need to know in pursuing a data science career. And to that extent, it's a challenging program in the sense that many times, and this is where I think the great big the skill is, that it sort of, you have to increase this skill of problem solving, adaptability, and learning on the fly. And the curriculum is structured such that you will and ultimately to go through it. But that proves to be a very adaptive skill once you leave the boot camp. And it's certainly something I exercised on the real client projects. And of the real client projects, I think that is the greatest benefit to the boot camp experience, because one, it does solve the problem of, well, I want a job, but in order for you to have a job, you need experience. But for you to have experience, you need a job. So the real client projects take you out of the bootcamp environment. And the moment you do, you become a consultant for Beam Data. And in that position, it's this sort of wonderful transition between sort of like the academic setting and the real world, where you can now apply any and all of the skills that you learned in the boot camp, have the wherewithal now to develop further skills, and apply them to real projects that you can then leverage and put on your resume to get into the door, to get interviews, and ultimately to to gain employment in the data science field. So to that extent, what are the real client projects? Well, we're at any given time engaging with a number of clients who we have a relationship with, and we are trying to solve, as data scientists and as data science consultants, you will and we will ultimately try and solve business problems. I always say that is actually the function of the data scientist. You have to solve business problems, and if I can simplify those business problems, it's, can you save me money or can you make me money? And so much the better if you can do both. And looking at this particular one that I'm about to highlight, what we did here is we had a client who is a sort of major media publisher in Canada. And what they ultimately wanted to do was increase the user engagement. And the way they wanted to do that was through recommender systems. I'm sure everybody has encountered recommendation systems, whether it be through YouTube, Amazon, Spotify, Netflix. It seems everybody is recommending something for you to engage with. And here's no different, because ultimately what we were doing was recommending you articles that you might be interested in. So this ultimately furthers engagement because, as with recommender systems, the longer you are on the site or the platform, the more you are engaging with the content there, the more opportunity there is to sort of take you down the sort of customer life cycle or funnel, or to, well, it's entirely up to the business and their objectives. But the chances are, the more you engage with the platforms, the more you like it. And the more you like it, the more you might buy from it and continue to use it. So enter recommendation systems. Now, for our client again, if you are on their site, what happens is you will be given 3 or 4 recommendation systems. Those recommended articles. And now those recommended articles are ones that we feel that you will engage with based on past history. And if I just go to the next slide, you can see the business objective and the manner in which we try to go about solving it. So again, one was improve the click-through rate, so that when you see an article, you will click on that article and engage with that article, and conceivably be happier with the product, and continue to use it. Now, in order to do that, we developed 2 models: a content-based recommender system and a user similarity or collaborative filtering recommendation system. I'm just wondering, does anybody know the difference between the two? And might you be able to provide an example?
Is this slide will be available for download?
These slides? No, I'm afraid not these slides. But what a content recommender system is when you engage with content, for instance, like a movie, that gets tracked. And so if I'm watching, say, The Godfather, a series of things will be noted, like the genre, the actors, the director, and it will search out similar like things to The Godfather. So it would be probably no surprise that based on the content of what I'm engaging with, they would recommend me Godfather 2, or maybe it's an Al Pacino movie, or maybe it's a Francis Ford Coppola directed feature, or something with the same cast. So this is a similarity, or sorry, this is a content-based filtering recommendation system. And to that extent, they can get very personalized because they try and leverage your preferences. There are a couple of issues with that, in that if all you get is your preferences, then long term, you won't have any sort of novelty in terms of what you get recommended. So there's not a lot of potential to discover something new off the beaten path that you wouldn't normally have engaged with. Well, to some extent, the user similarity or collaborative filtering recommendation solves that problem. And what happens in this case is, say, I watch a film, I watch a Godfather 1, Ricardo watches Godfather 1, and they look at our viewing habits and say, based on this sort of network, Ricardo goes ahead and watches Godfather 2, and he gives it the thumbs up. And the thought is, well, Alex sort of likes the same movies that Ricardo does. We can recommend him Godfather 2. So the collaborative filtering depends on in sort of a collaboration amongst a network of individuals. But this is also with its drawbacks, because one, the network, or the network of individuals sort of collaborating, has to be extensive enough and wide enough so that you could get recommendations. And to that extent, Ricardo might see a video, watch a movie that I would have never occurred to me, but he gave it a thumbs up. And based on the recommendation system, they go, well, okay, let's pass that along to Alex, who would have otherwise not have engaged with that film, and maybe I do like it, and then that recommendation pays off. So in some sense, one tries to balance off the other, and both of them have their pros and cons. So what do? Well, you develop both, and then you test them, and therefore it goes through A/B testing, and that's sort of done on the client side. But ultimately, for this particular project, it was the content-based filtering that won the day. Slide. Oh, yes. So this is, the exploration or examination of the collaborative filtering. So if it's read by both users, you can see that the one read by her gets recommended to him. And in content-based filtering, it's just you engaging with the material, and the similar material is then recommended to you. I won't go into tremendous detail about this, but this is sort of the architectural infrastructure of how the recommender system worked. So you would be on the website, your article history would be tracked, that would be logged into the AWS Amazon Web Services and stored in various tables and in that it would store the metadata on those tables. And then based on a user history, it would conduct a similarity search looking for articles within a 60-day window that you engaged with, so that it would give you 3 to 5 recommended articles that were similar in nature to the ones that you had been engaging with. And then that would be sent to you via API and land on your website. One of the problems with this particular project was there was a lot of data. You could imagine a major media publisher has a lot of readers. Those readers read a lot, and there are a lot of articles. So we had to work through an enormous amount of data, which ultimately made the AWS services a necessity, and big data computing platforms like Databricks, which can sort of carry that load. So that was definitely one of the challenges with developing the recommender system for the client. As I already mentioned, the role of novelty in long-term engagement. So if it's just a content-based filtering system, I might get bored of all the same articles without having some degree of novelty introduced. And there's always an issue with recommender systems regarding the data sparsity. So
This is not similar to what happened when you log into YouTube.
it depends when you log into YouTube, because if you log into YouTube and you've already engaged with any number of videos, then there's enough data on you where we can recommend something to you based on your user engagement. But there's always the problem of a cold start. So what happens when I just sign up to YouTube? What are you going to recommend me? I haven't touched a video. You don't know what I like. So to that extent, that's the cold start problem of a content-based filtering system. On the flip side, though, what if I'm just joining this what if I'm just joining Spotify or YouTube, and it's no, and there's nobody else there. Well, the example doesn't work. Everyone's on YouTube, everyone's on Spotify. But if we are joining a newly formed platform and there's 5 people on it, then there's an issue of data sparsity. It's a cold start problem because it's like, well, we're just getting going. Who knows if I like the same thing as Ricardo does? So that's ultimately an issue you have to confront with either recommender system, potentially anyway.
Yeah, sometimes you start from zero, or sometimes you start with some demographic information based on a login, depend what you capture.
Yeah.
And then if you capture, for example, you force somebody to do login, and then maybe did some geographical from the address, and maybe from his age, I don't know, but something like this, then you have sort of not zero, but not 100%.
Yeah, ideally. And that sort of ties into one of the other challenges of recommendation systems, is that the best information is the explicit user feedback. How do I know that Ricardo likes The Godfather? Because he gave it a thumbs up, because he rated it 10 out of 10. He pressed the like button. This is the prime information. If we have this information, our lives are so much easier. The unfortunate thing is Ricardo's not pressing that like button. He's not giving it a rating, as most people sort of often bypass this explicit rating. So what do we do?
Then you go
Well,
to historical usage. If you have historical usage based on some groups, then you can tailor your initial recommendation not to be so vague. Maybe you will be more targeted, but not 100%.
yeah. So what we're left with ultimately, even with historical data, is an inference based on user behavior. So if I say I'm watching Netflix and they see, well, Alex came to the end of the movie, like he watched the movie, he didn't look at the first 5 minutes and then click it, or move to the next one. Because if we do, we have to sort of infer something. Well, if he only watched it for 5 minutes, he must not have liked it. Maybe I had a call and I had to leave abruptly. Or conversely, he watched the whole thing. He must have liked the film. Maybe I just kept it on in the background. So it's an imperfect way of judging, but oftentimes it's the richest data available. It's just
This is lead you to the next stage, which is basically the machine learning. This is the improving the model. It's over time you improve the model over time, and this is the whole ML idea.
Yeah, absolutely. And those are the
Listen,
wonderful.
I just started a few weeks ago. even not few weeks, maybe 2 weeks, 3 weeks.
Let me just segue a little off script and not on the slides, because with this same client, this was sort of, I want to say recommender systems are so 2 years ago. Everyone is trying to leverage recommendation systems. They're a massively powerful tool for increasing your bottom line, massively powerful. But as it stands right now, what's really in vogue, what people are in demand for is leveraging generative AI. And typically that manifests itself into creating some form of chatbot that will increase user engagement on their website. And for this particular client, we are now, we have developed a chatbot. But the great thing about the chatbot is, and I'll tell you how it works. So a user will come onto the website, and it's for personal finance articles.
Mm-hmm.
The user will come on to the website, engage with the chatbot, and ask a finance-related question. What is a TFSA? When's a good time to retire? Now, we will have a corpus of documents that we instruct the chatbot to turn its attention to in order to generate the answer. So to that extent, the answer will be
but you have to develop a decision model based on the chatbot question and answers. Behind it has to be a decision model.
In what sense, the decision model?
In sense that if he asks this question and you give him an answer and he agree with the answer, then you go to the next. You know, it's like a decision tree.
True. So, but in our particular use case, what we're ultimately doing is we have a number of articles and we've vectorized them inside of a database.
Yes.
And we get the query. That query also gets vectorized, and then we instruct the retrieval method to find me the 3 closest, 4, 5, whatever, closest vectors to this question that itself has been vectorized. We retrieve those, and the large language model then takes that answer and let's just say puts it in a more palatable form that you now have an answer to. Now, this is also increasing user engagement because you're on the platform. However, the great thing about this in this particular project and use case is, and I'm going to circle right back to this project, in the event. So first of all, when you ask those questions, what ultimately gets outputted in addition to an answer is the links to those articles that exist in the vector database that comprise.
But you basically, your source of the article is the web, or it's your private or enterprise database? Where's the
enterprise? Sorry? All private articles.
All private articles. Okay, fair enough. So you store them in a database.
Yes. Yeah. It's a RAG chatbot, so retrieval augmented generating chatbot that generates answers from its own personal corpus. And the benefit of this, insofar as I could circle back to this recommendation project, is when it provides you with an output and it's an answer, it also gives you the opportunity to click on any of the articles that comprise the answer. And anytime you click on one of those, that gets read back into the database and ultimately comprises greater detailed information about your preferences, so that we can then recommend articles that
this is your feedback. This is your feedback process to next time to improve your targeting, you know. So if the same person log in, or a similar person, let's call it a similar person, you already be more efficient with coming with the right answer, instead of him wasting time. I don't call it wasting time, spending time. Maybe maybe it's only 15 minutes. So there's a chance that within the 15 minutes, either you missed the boat or you didn't miss, or you just given the right answer, the right paper, you know,
Yeah, it's sort of like, so it's like
from your proprietary database.
yeah, so it's like one hand washing the other in terms of the clicks generated from the chatbot then will go in and inform our recommendation system so that we can provide better recommendations for you when you are on the website and not interacting with the chatbot. So the two sort of have now
Yes, intermingled,
yes,
like it's intertwined. It's
yes.
intertwined because the learning process is never ends.
No, not with machines and not with humans.
Exactly, never ends, because the permutation and the probability to find like a it's infinite knowledge, like that's what you're in the situation of infinite knowledge.
Yes, yeah, it is. And insofar as you're willing to go down that road,
I,
it really is a lot of fun. It is a
I,
lot of fun.
I'm interested to ask you a question, if I do, if you don't mind, right? Sorry for jumping in. Okay, I'm coming also from the big data, and many years, you know. And what I did, I developed at the time an EMR system, medical electronic medical record for a huge hospital in Canada, number one, I would say, pediatrics. So I was dealing with a large amount of data before all of this, the data science becoming such an important an important tool. And now I have so much data, but how we go back and analyze it and find a recommendation there, for example, and this is operational recommendation regarding inventory management, regarding time management, regarding room management, regarding equipment management. You know what I mean? Based,
Mhm.
what I'm saying is if you don't, if you go beyond the descriptive analytics, you go to prescriptive or prescriptive. Basically, this is okay. Here is your issues based on your historical data. That's where we recommend to you. Okay, and I would like to know if you can talk about a little bit about it. It's
The
how we can harvest existing data which exists for many years, and organization have the tendency to stay. If it ain't broken, don't fix it. This is basically the motto in life. But this motto in life basically put them in a situation that a lot of knowledge that you can extract from historical data is not available to them. But the machine learning and AI should be the tool to help you to create a predictive or prescriptive. I would say prescriptive analytics is the best.
yeah, you know what though? I'm going to tell you. That's the nature of machine learning and AI, in that you can take a look at this historical data and make ultimately, whether it be through ML or other means, you are making you are hopefully reliably making predictions that would improve some aspect of the business. And sometimes that's the job description. But the thing that actually I always say is that's the story that has to be told. So it's not readily clear to stakeholders why what you're doing is important if they can't understand the story behind it. And just as a personal aside, one of the most fundamentally underdeveloped skills insofar as I'm concerned, in data science, is the ability to present and forward a story such that it is compelling enough for stakeholders to take notice, understand clearly, and then allow to take action on those prescriptive analytics. But sort of segueing into a more sort of concrete answer, I think it's sort of a great opportunity to segue into the next clip, which Ricardo will be talking about in terms of time series forecasting, and that might answer some of the questions around how we could leverage this information, position it in the future, such that we can make accurate predictions and decisions based on those predictions.
Yeah, hello everyone. Hello,
Yeah.
Steve. I do think I do have something similar I can share with you. But thank you everyone for being here. But let me just quickly introduce myself. My name is Ricardo Alamo. I do come from a STEP background. I was a civil engineer, and then I had an MBA. I started my data journey with a marketing agency, which I worked as a data analyst for 2 years. Then I decided that it was maybe not technical enough for what I needed to do. So I I did the bootcamp, data science bootcamp with WeCloudData, which for me was life-changing. To be honest, it really helped me to improve my skills, understand a lot of what I was doing wrong on my job as a data analyst. And after that, I have the opportunity to work more with BIM data, and I got more experience with more projects. And I think before going to the next slide, I do want to address your question, Steve. I do have something really similar. I worked in a project really similar of what I think you are trying to achieve. This was it wasn't a hospital. It was an institution that it was trying to get information from a lot of hospitals, and they did have, I think, for 5 years of historical data about I don't know it's not demand, but let's say hospital usage for how many beds they were using in
Yeah.
that particular
This
day.
the bed management, like province-wise or state-wise. I don't know. From here, you are from Canada or
Yeah,
from
in Ontario.
Ontario?
Yeah.
Oh, okay. So we are neighbors almost. So, so how the province works, because because it's all managed by the government, and then they give funding to the hospital, but they have to do also forecasting.
Yes.
And a lot of the forecasting is coming also from analysis of the disease that people might have, and the population growth.
Mm-hmm. Yeah, so what we did in that, well, I cannot say a lot because I do have an NDA, but what I can tell you is like I did, we focus on holidays because holidays were peaks of usage on the year. We did use historical data from the hospitals, and we tried to categorize them in some way, which it could be like emergency use or just family doctors, things like that. And with that categorizations, we did get like the demand for every day. We did some, I will share with you right now. It's not going to be particular for that case, but we use the same tools. There's an algorithm called short, um, long short-term memory will help you to get this seasonality stuff because there's somewhere which that was what we wanted to do. We wanted to get like those holidays there in the model. So that'll help a lot. And we also have to clean some of the data because
Yes,
people, the
yes. Oh,
hospitals
yeah. Oh,
don't.
yeah.
Yeah.
Otherwise, your prediction might be completely wrong, And when you do data cleanup, you have to make an assumption, and this assumption has a probability. I've been in all of this, and when I designed the databases but which tools you use? You use basically Pandas and Jupyter and this one
Yeah.
too, right?
So because we were working with a limited data set, we couldn't get the complete set. because also for data privacy.
Yeah.
We just use pandas and
Jupyter.
Jupyter
Jupyter?
notebooks, Visual Code.
Yeah.
We did use AWS and Docker, but it was more for for the deployment of stuff.
Yeah.
So we were deploying the model and we needed to do an API for them. So for that part, it was more AWS. But for the initial analysis, it was just pandas, and we use the scikit library for the traditional machine learning models. And then we change a little bit, which you will see here also the long short-term memory algorithm,
Mm-hmm.
which I would say that really helped us. And I think I can explain you right now why that it was a good one.
Okay.
Can you go to the next one, please, Alex? So these ones, this one is a bit different, the problem that we have at that time. Yeah, this was another project. The project was like they wanted to, I think this is in Ottawa, they wanted to recognize when a hydrant has a leakage. And the way they did it, it was very clever in my opinion. They have like this sensor which detects acoustic signals, right? So the idea was like when a hydrant is having a leak, you can hear the difference between normal usage and when it have a leakage, right? Can you go to the next one, please? So this is exactly what you can see, right? So on the top, you can see what it will be like a normal behavior of a hydrant that doesn't have any leakage. And at the bottom is one that has leakage, right? It's a bit hard to read because the y-axis are different, but you can see that on the top it goes from 1.5 to 4. And that's RMS is just like a way to detect sounds. And the other ones, you can see that it starts at 7, which is pretty high, and then it goes to 3, and then it goes to 9, no? So it's really going above what we normally consider like an average, right? And can you go to the next one, please, Alex? So for time series stuff, you always need to analyze historical data, right? And for detecting leakage and not leakage, which was similar to the hospital stuff, right? Also because we needed data for the holidays and data from the days that were normal. So you always gonna need data of what you want to do, right? In this case, we wanted to detect leakage, so we need the data with leakage. And
Just a quick question. What's the it's electrical or it's water when you're talking about the noise?
water. It's just yeah,
Water,
just the
water.
noise,
Okay,
yeah.
water. Okay, water. So
The
basically,
noise, yeah.
so what you say, if the noise was reduced, then it's about the leak. Then you identify as a leak.
No, if the noise is if you have more noise, then you
Yeah.
have a leakage. Because these are like fire hydrants, right? For firefighters. So if they have a leakage, it will have a lot of pressure, so it will do a lot of noise, and you can detect that. You can detect the increase of noise. That's
So
what.
so you had to physically have sensors putting
Yes,
in along the line, and this
exactly.
is basically a project in IoT
Mhm.
data collecting data.
Exactly. Yes, we have that data, and we use it to do this.
Yeah. Okay.
Um, the other thing that it changed, which is also important here, is on the start seasonality, and you will see why, because these sensors, they detect noise, right? So
Yes.
think about it, like it's not gonna be the same noise at midnight when you don't have cars, you don't have people, you don't have anything, and when it's like around 9 a.m., right, when everyone is moving around. So you need to detect. That's why seasonality is important here. You need to detect those variants of the data when there is more noise and when there is less noise, depending on the situation that the hydrant is at the time. And then it just like try to review the method and trying to see that it's really catching that what we want, right? Can you go to the next one? Right.
So the question is now what the historical data, because the moment a leak is happen, is becoming historical data,
Yeah, exactly. Mhm.
right?
So
So
this is
now,
just like let's say one of the things that we did. This is like this is what I was telling you, long short-term memory algorithm. And then you will see why it's better than traditional machine learning like XGBoost or linear regression or things like that. This is just the modifiers that we use. We use a robust scaler, and then we just split the data, and like always, train and test, and then we feed the data and we predict the data, and then we have like the inverse scaler, so we can have the true scale of the noise, right?
Can you talk for a minute? How much data you had to collect in order for this model to predict correctly? Like
So that
because
was
machine learning is millions of records, no?
Yeah, so this one, and you will see now, like it was a little bit limited because as you can see here, it was from June to March. So it wasn't the complete year. That was something that could, mm, let's say, if you try to do, let's say, July or something like that, the model will not be able, it will not perform as well as the other month, right? Because it's not training on those years. And the data was a lot because the sensor was giving us data every minute. And we have around 50 different hydrants we were using as a sample data. So yeah, it was million of rows because we have like
some of the data was noise meaningful because it collects all the time, and as you say, 9 o'clock in the morning, it might give you a noise, but this noise is really not relevant to you, relevant
yeah,
to the model.
exactly.
So how you filter this? How you say that, okay, in one hand, the 9 o'clock in the morning is not relevant to you. However, in 9 o'clock in the morning might happen, issue with the hydrant. Might, burst, one of those hydrant can burst, and it's relevant to you. So how you distinguish how you filter it?
Yeah, can you go to the next slide, Alex? So this is the data itself, right? Again, it's like y-axis is the noise and x-axis are the days. And as you can see here,
Yeah.
this was a normal one, and it just went to 1.5 to 3.5. And here is what I was telling you, like this long short-term memory algorithm can help you. Because when you're doing machine learning, one of the things that you are calculating is, or you can calculate to get let's say the validity of your model is
Yeah.
the root square mean error, right? So if you can see here, the XGBoost goes on the middle of all the data. So if you calculate the distance of points, which is part of the root mean square error, you will see that they don't are that far away. So when you do XGBoost, you will have like it will appear to be a good score, but it's not really a good score because it's just putting a line on the middle, and that's it, right? So it's not really helping you.
But there is a way in machine learning to calculate the accuracy of the model, no?
Yeah, exactly. So, but that's where you need to be careful of what you're doing, right? Because if you're checking just the scores that that the model is give you, even if you see those scores are good, they might not be good for the purpose that you want, right? So in this case, what I'm telling you is like, if you compare all the points of the blue line and you compare it with the points of the yellow line, the distance between those points won't be that large because the blue line, which was forecasted with the model, is in the middle, right? So even if you have these variances, it's gonna tell you that you have a good score, but not really. Let me show you. Can you go to the next slide, Alex? So go one before.
No, this is too much, no?
Yeah, go back, please. One more. There, yes, there. So this is LSTM, the long short-term memory stuff. And now, as you can see, the blue line is following the trend. And that's exactly what we wanted. It's not a middle line. And if you compare, when we were doing this, we were comparing the R score and we were comparing the mean square error, they were really similar models. But this one in particular, when you graph, when you chart the stuff, you see that is picking what we were talking about, which was, okay, this model is picking the seasonality between days, that you are having more noise in some days, you're having less noise in other days.
Let me ask just a generic question, maybe more. How much of to be a statistician you need to be? Like how much of knowledge in statistics you need to have? I'm not talking about machine learning, just statistics, because what you're talking here is basically statistical models, no?
Yeah. Yeah, they are statistical models. They are algorithms that follow statistical models. That's
But
it.
you as a data analyst, how much knowledge you need to have in this? Let's say most of us didn't learn statistics, okay?
The problem is that, and maybe that's a question more for Alex, because I know he didn't have like a STEM degree before. For me, this come more naturally because I'm an engineer, right? So I did have like
I'm also engineer, and I came from a good background in statistics and everything. However,
I
it
do
looks to
think
me,
if you are an engineer, I do think that you have enough statistical background
yeah,
to understand it, because it's gonna be there. Yes, you need to learn a little bit more. You need to understand what the model is doing. But for example, when you learn what is a linear regression, if you understand what
yeah,
is R score, if you understand what's the root mean square error, which is just, the distance between points.
yeah.
If you understand those kinds of stuff, then you are good. Then yes, you will need to learn more, because not all the models are that straightforward. For example, when you are on decision trees, there is like, you need to learn a bit more. When you go to deep learning, is completely other stuff that you need to learn, and that's more difficult to understand, but still having that background helps you to keep learning. Yeah, and can you go to the next slide, please, Alex? So this is exactly what you were asking me before. So the blue line is the forecasted one. So this was trained with all the normal hydrants, the ones that didn't have any leakage. And you can see that they don't go above 2 at any time of the day. Okay. So
Which graph? Sorry, which graph you talking on
the
the
one on the left.
the one of the left? Okay.
Yeah. So the blue one is the forecasted one. The blue one is the one that the model gave us, right? And the yellow one, it was the actual value, or the value that the software
the
was
actuals,
providing to us.
but and what is this 0, 20, 40 is what is the number of
They are just that minutes on a particular day on when the leakage happened. And the y-axis is just noise levels. And what we did is that you have a threshold of how much does the difference between points are. Like, that's what we are saying here. In red are the anomalies based on a difference and RMS error, root mean square error threshold. So if they go, like, we have our baseline, what we know the hydrant's gonna be on a normal use. Those are the noise that we have, and those are what we are forecasting, right? And if they go above a threshold, then an alarm is raised, and then we can understand, or we can detect that was leakage, that hydrant has a bit leakage. And because you do have data from all parts of the day, and do you have enough? I think we have like 6, 7, 8 months. We could have like this, let's say, average, and then you could just detect the anomalies. That was what we did.
What conclusion you have from this, or what recommendation you have from this to the business? For example, how many crews of technicians should this company, hydrant, whatever, should employed, what, or to predict when it's going to happen? What is the business recommendation? Because business recommendation is always associated with money.
Yeah. So the hydrant, remember, there is pipes on the ground, right? So if you have a leakage, you won't see the leakage until later. So when the problem is bigger. So this will alert the, the municipality or the firefighters or whoever that you have a leakage in that particular pipe and that you have to go now because the noise level is too high. So that is what this model is doing. It's just comparing what normal usage is gonna should be. And when you have this difference of big difference, it's just gonna give you a label or it's gonna alert you. And that alert was sent to the person who the maintenance guys, who can go and fix the problem before it gets too big.
So you, in other words, you basically, your model is filtering the noise.
Yes.
Instead of sending like false alarm. It's like
Mhm.
somebody has an alarm in a house and the alarm is turned off, and then it's a false alarm because he forgot to press the code, pressing the secret code. So here is the same. It's basically filtering and preventing false alarms.
Yeah, exactly. Yeah, that's it.
But this is important. I think this is related back to what Alex said at the beginning. Is a part of how you sell it. Is a part of the story. If you came to me at the beginning and say, start from the end of it. The purpose of this exercise was to save them false calls, because then it's reduced the number of crews that they need to hire. B, it's reduced their costing, because when you dispatch a crew to handle a leakage, you have to give them the car, you have to give them the time, you have to pay for them, and so forth. And they come to the place, and it's a false alarm. They have to call back. Meantime, there's a real call that they didn't address, So now, all of a sudden, you need 2 crews. But in reality, 1 crew is enough. And I think this is the story that has to be told. Am I right, Alex? You're mute. You're mute. You have to unmute yourself.
Yeah, I would concur with that. Again, it's all about, I think, sorry, not to digress from what's already been covered, but I think too often we operate, exclusive to other data professionals, and we communicate a data language amongst one another naturally. But when you get outside of that environment and when you speak with the relevant stakeholders, you have to
Exactly.
you have to be aware
You
their
have to
language.
speak money. Exactly.
Yes.
They signing the check.
Yes.
And if you come to them and they don't understand you, they will scratch their head and say, "What the hell you did from here?"
It's
and
like,
apparently you did, and apparently you did an excellent job. If I look on this, in my words, I would say techie. This is too techie. And based on my experience, I had to learn a complete. When I was in the hospital, I had to learn a complete new jargon, new language, the clinical language, and then I translate my solution to their clinical language, and this is the way I bridge the barrier, which Alex said.
Well, I will say this, and I'll tie it back to the curriculum of the boot camp, because in the boot camp there are any number of, like, it's almost like on a bi-weekly basis that we have, and that you undertaking a project provide a presentation to. And one of the things that I was teaching assistant for that boot camp before I became project manager. But one of the things I always stressed was the time limit that we gave to you to present your project, and the language that you employed to present what you did. Because at the end of the day, if you can't say it in the time that is allotted to you, then everyone's moving on. Everyone lives busy lives, and to the extent that
you lose attention, and here you go, out of the window.
Absolutely, because even if you're wonderful, you're a wonderfully compelling storyteller, and you take half an hour to unfold your story. It's like, I've only allotted 15 minutes before my next meeting, so I have to go.
It's called
Yeah, I agree with the stakeholders. Yeah.
elevation
Elevator
speech,
pitch. Yeah.
elevator speech, elevator. And this you learn. I engage with Mars Discovery on a completely different topic, and
Yeah.
I did it, and I know exactly. You got 15 minutes to present your business case,
Yeah.
and then you can attract investor or not. You know, it's the same thing. You have to, right, Alex?
It's the exact same thing, and you have to translate your language such that it registers and grabs their attention. So, you know, if I let off with the next 15 minutes, I'm going to show you how you're going to save 25% in this quarter. Do I have your attention? Chances are I'm listening.
Yes,
you know?
exactly. Because you talk the money, the business language is money. If you can put more money in my pocket without me spending additional money to make it, I'm going to listen to you.
Yeah, and I think that there's, to some degree, there's a balance, because you do at some point want to outline the approach and the steps you took, just to ensure that, you know, to relay to them.
Establish credibility.
Absolutely.
But you will not be able to establish credibility if they don't understand what you're talking to them.
Absolutely. So you don't want to go into the weeds and talk about this, that, and the other thing, because they'll have no reference point for it, where you would, and data professionals would, but for them, it just, you lost them. So it is really, it's a soft skill that is so important, and so underdeveloped, in my opinion, anyway. And
I agree with you. I know what I agree with you 101%, you know, based on my personal experience.
Yeah, it's amazing. And if
I learned this on the hard way, you know, I learned this because when you write a program, regardless if it's in Python or any other thing, or Visual Basic, whatever, and you all entangle in the technicality, when you come to present it, they don't understand you. You have to present a business case and tell it, here the way I solve it. However, if you want to go into the technicality, we can have another session, but that's what I did.
Yeah, and absolutely. And I remember speaking with a bank executive, and she basically says, like, if you don't grab my attention in the first minute, you've lost it thereafter.
Exactly. You know? And I had the same thing with the executive in the hospital. Those people give you 5 minutes. If after 4 minutes you miss the boat, then you're not out of the door, you're out of the window.
Yeah.
Yeah, in a hospital, I guess it's going to be super short, the time that they give you.
Exactly. And especially if you are in a teaching hospital, which they are super smart guys, you know?
Yeah. It's amazing. You become so much more powerful in the room when you present, and you present in a meaningful way that registers on the stakeholders. And to that end, if they understand you conveying what it is that ultimately helps them, they will appreciate you. They will appreciate you and the steps.
You know, let me tell you a story, okay? I had to solve an issue of waitlist, patient waitlist. It was huge waitlist.
Mm-hmm.
And I had to get a resource to it, but how I justify it. So what I start from the end of it. I told them, listen, if we save 1 patient a day, we do more. Actually, we increase our, you know, number of cases, number of exams that we do per room, 1 more per day. And then I showed them 1 more per day. It's how much per week, how much per month. And all of a sudden, the number becomes so big. Are you going to listen? Yes, I'm going to solve it. I'm going to do it. But that's what I need. So I got all the resources, all the attention.
Yeah.
Because I sold a compelling story which talked to them. Okay. It's not money. It's patient waitlist, because it's issue of the patient outcomes. It's issue of the patient safety, and also the government is on the case with the waitlist.
Yeah, no, I believe it. It's great, and it's a difficult thing to develop, because again, we're largely in front of the computer most of the time,
Yeah.
with the screen rather than a live person. So, you know,
It's up to you and up to you. It's a question of experience, life experience, and how you have to go multidimensional with yourself. You have to go up level, talk to the business guys, and then dive down to the technical and talk to the technical team and go up and down, and wear many hats at the same time. That's the way I conclude it.
yeah.
Many hats, and you have to translate it from one head to another head. If you talk with the, I don't know, the blue head to the business guys, and then you talk with the red head to the technical guys, but when you wear them at the same time, you can do the conversion right away.
Yeah, I sort of phrase it as you have to know many languages, all of
Yes.
which are inevitably going to be like, English, but many variations of that, because communication, and this is something I'm very passionate about,
No, I agree with you.
has to
Communication
be,
is important.
you have to speak the executive language. You have to speak
Yes.
technical language. You have to speak the client relation language. You have to
Yeah.
speak the coworker, the employee language. And within those, like, in oftentimes, with the management of projects, with the consultants that we're engaging with, I find in some cases I have to, it has to be in some sense tailored to specific individuals within the tier of the people that are developing the projects for us. So you might hear it one way and Ricardo might hear it another way. And if I now get that feedback, I then know that, okay, I'm going to tailor my presentation or my instructions or anything to Ricardo's preferences, because I know that's the sort of the language he speaks, whereas you might speak a somewhat of a different language. And if we speak somewhat of a different languages, and if we continue on, we might start at a very close point, but the longer the conversation goes, the further apart we can be, and then we can leave with having an incorrect understanding of how best to proceed.
Walk a mile in your shoes.
Yeah.
That's basically it is. And I agree with you. And this is in any project, because when I lead a project of 30 or 40 people, each of them understand differently, and each of them come with different skill set, and they do different. One is doing the design, one is doing the databases, one is doing the programming, the other one is doing the testing. And you have to make sure that the pendulum, I call this the pendulum of the requirements, is always stays on zero, okay? Because if you move from the zero, you already miss the boat. Because remember, any project that you deal with computers, regardless if you do machine learning, AI, or just develop a database, by the end of the day, it's translated to assembler language 0101. And if you miss it by 1%, it's translated wrong. And then when you press the button, you get the wrong results.
Yeah. We're of the same mind. Yeah, I believe that.
Yeah. It's called the pendulum of the requirements.
Yeah, I like that. Sorry, Ricardo. Did we hijack the presentation? Did you want to?
No, that was the final stuff. We do
okay.
have a bit more of the. Well, I already talked about this, that we have limited data, but next slide is just the other projects that we talk about them. I don't know if you want to go through those.
I think I delved into the chatbot development, the loan prediction, yeah, all of these things related to time series forecasting. I haven't myself I have not worked on the website SEO, but there's
the website SEO, I did work on that. It wasn't that difficult. It's just like we did have like a web scraper that was looking for if you look for, let's say, vacations, it was looking for the most popular words of the 10 most popular websites, and then it will give you those words back to you, and then you can write your, let's say, your blog or whatever using those words, so you can try to be on the first on the first results of SEO.
Let me ask a question. As a data scientist, are you also engaging in developing website per se, let's say go and designing them, or this is something
No,
else?
not really. We
Exactly.
normally
Okay.
deal with the backend. We not deal with the database. We did with the API, but we
Yeah.
are not in UX or front end developing.
Thank you. Thank you. Because when I looked on the entire course of Python, I saw this,
Oh,
designing
Django.
web and this
Uh,
Django. I left it. I said, it's not something that I'm really under my focus. My focus is I started with how to read data, extract data from SQL database, because this is my source of information. And then what else I can do. And this is where and then I went to the machine learning, and then I learned about those models. And one of them is the libraries of pandas and panda, sorry. So I'm on the right track. Okay. Very good.
yeah, you're in the right track. After that, there is like this scikit library, which is great for also learning traditional machine learning. I would say
Yeah.
go to that because they're also like great. And there's always new things coming, but I think the base is probably pandas and scikit.
Yeah. And the next question is there's any limitation or sorry, is there any way that we can have a conversation or chat after the meeting? Let's say, establish a relationship, because it's we can have the phone numbers or something like this.
Sure, of course, yeah. We can. Are you with LinkedIn? Connected to
I'm
LinkedIn?
LinkedIn. Yeah, I'm on LinkedIn, but I can drop you my phone number and my email in this chat right now. I'm not afraid to do it.
Well, maybe we
Yeah,
could
yeah.
end the
By
video
the
and
end,
do
okay. By the
that.
end of it, yes. I'm on
Um,
LinkedIn. Yeah.
I will say, but and this is I haven't validated this. It was told to me by my instructor, but just with respect to sports betting projections, ultimately this is a big money endeavor for businesses. But I heard, and again, I have to verify this, but apparently there was somebody who was so adept at the creating a machine learning model that would predict the outcome of horse races. That this person, his model was so good that he had won a lot of money from it, and then slowly sort of faded into the ether. And where he is at this point, I don't know. But that's the story I heard.
Yeah, because he was afraid that the legislation or even the authorities will cap him,
And anybody looking to capitalize on if that model is that good, he's going to become very interesting to a lot of people who engage with betting. Let's just leave it at that.
but the question, if he going to sell it, I'm doubt it.
Yeah, no. If you can make more money just using it, yeah.
I think he was afraid from blackmailing. I think he was afraid from somebody
You remember
may
of a movie, Alex? There is a movie called P, and it was a guy who developed like a model to predict the stock market price. And it's about that. It's about the same thing. That he predicted prices of the stock market, and then the government gets suspicious, and they get, people start following him all the time, and he needs to be, hiding and all of that.
No
Yeah.
doubt. You can be good, but you can't be that good.
Yes.
exactly. But this is something similar to the famous movie The Wolf of
The Wolf of Wall
Wall
Street.
Street. It's when they selling short, So the only catch here was that they didn't predict when everything will collapse, and this is when they lose their shirt.
Yeah.
Yeah.
Oh yeah, there was maybe that was the Big Short. Remember the Big
They're
Short?
selling short, and the Wolf of
Yeah,
both
yeah,
of them,
yeah,
the Wolf of Wall Street.
yeah. The
One
Big
was DiCaprio, and the other one was, I think, I don't remember. I think was
Christian Bale?
Matt Damon, maybe, I don't remember.
Was it Christian Bale? The
Yeah.
Big Short. It had Christian Bale, Brad,
Christian Bale, yes, Christian Bale, yes.
who predicted the housing crisis.
Exactly. Yes, yes. But then selling short is the predicting the housing, you know, the mortgage, actually, the mortgage crisis.
The mortgage crisis, yes.
The mortgage crisis. And the Wolf of Wall Street, something like this. This is also completely corruption. Like, you know, yeah, this was
The smoke and
know,
mirrors of stocks and Wall Street, and absolutely the corruption that.
it's all the same, you know. You know, they got to predict the horse races. It's
Yeah,
he under the same umbrella.
pretty much, yeah. So then, what are your plans going forward then in terms of the direction you want to go with your career?
Me?
Yeah.
I want to get into data science. This is really my goal, and actually I just started, and because I'm a hands-on guy. My first challenge was to learn Python. I learned by myself Python. And I learned only the stuff that is related to extracting data, manipulating data, you know, connecting to SQL Server, and then you know, executing store procedures and listed them and printing them. I don't want to get into Django because it doesn't interest me. And I also start to do some machine learning. And this is where I want to go. I want to stay in the business arena. The website for me is like toys and games, you know.
Yeah. Well, what we
But
hope.
I'm more than happy to hear from you, your opinion and your guidance, you know, Alex and Ricardo.
Everything's really interesting right now because of the generative AI moment we seem to be in, and we will, I think, continue to be in, given that this technology is ostensibly still in its infancy and getting more powerful by the moment.
I believe that guys like me with so much experience in it and so much, not in AI, not in machine learning, not in this experience in data, you know, building databases, building solutions, and this is the next natural development for us, you know, going into
the base will always be the data. Like if you know how to have that, if you have like a good quality data, then the machine learning is something that you can do for sure.
This is actually when I designed the solution for the hospital. I built a huge database, and I built business rule, and I built it, you know, according to the books, normalization and the tables and triggers and store procedures and everything. So for me, data, I know how to build such a system that the you know, and this was a clinical system, so you don't allow to have a garbage because you don't allow to have anything that is wrong, okay? Because you make a decision about the patient life, you know.
Yeah, absolutely. But I will say, I think it's great. I have to temper what I'm going to say because of the great unknown impact of generative AI that's still developing and still emerging, and to the extent that we couldn't anticipate all of the effects of even the internet. No, we have even less of a clue, I think, about how generative AI will unfold.
But I can tell you one thing for sure. Any generative AI or any type of AI will not overcome the human being brain, okay? It will improve and it will make you more efficient, but by the end of the day, you have to make a decision. You have the one that really judge it if it's effective or not. The AI by itself will not overrun your brain. I'm telling you for sure. And all the stories that you hear about, oh, we're afraid. Yes, they're afraid from the AI because people going to take advantage on this. It's like the horse, you know, predicting the horse race. It's the same thing that happened you know, in the 30s when Henry Ford basically make the automobile accessible for the crowd, for the working guy.
Yeah.
So they start to use it on the road. Was many accident, so they decided, okay, first we have to legislate it, and then we have to put some rules, and then we have to put some you know, lights and this and there. It's the same thing will happen with the AI. Right now, the AI is like the automotive in the 30s. It's everybody is running wild, you know?
To some extent, and I will say, oh, by the way, Javier, yeah, by all means, let's connect on LinkedIn, and if you have questions, please feel free to chime in, or if you have any thoughts on this conversation, because what I wanted to say is from a certain perspective, based on generative AI, I think it's a good time to enter the field because of it's never been more accessible, right? Because
Yes.
of the power of and the speed of generative models like ChatGPT, OpenAI, right? In that, whereas maybe 5 years ago you had to be fairly proficient like at Python, especially the further in you got.
Yeah.
Now, you know, it's a question of, can you master your prompt so that you can get a masterful output. So to that extent, it's democratizing the field, in that you will see people probably from all types of backgrounds enter because of that accessibility. Where the level of automation occurs with Gen AI is still to be determined, and how that impacts everyone.
It's like sorry for jumping in. It's like ChatGPT, right?
Mhm.
If you don't know how to ask the question, you're going to get garbage.
Yeah, yeah. And in some, it's interesting because in some cases it goes back to what we were talking about earlier in terms of clearly communicating your thought, your prompt to the machine, such that machine goes, oh, I get it. You want
Yes,
this.
exactly. And oh, I get it, depend on the question, how you ask the question.
Yeah, it does. But it was funny, you know,
It's a
chat
good productivity tool. I'm telling you, it's an excellent productivity tool.
it's an
Oh yeah, for sure. Yeah, it saved me a lot of time
Yeah, exactly.
just to
Exactly.
yeah, just to find errors in my code. Like it helps me so much.
oh my God.
It's especially for us as ESLs, you know.
Listen, I will tell you this. There was a OpenAI AI ChatGPT power outage yesterday. And
Yeah,
I
okay.
imagine the whole data community was at a standstill until everything was up and running again, just because of everyone's newfound reliance on ChatGPT. And what they found actually was, between seasoned data professionals
Yeah.
and less experienced data professionals, um, those data scientists who had less professional experience but used ChatGPT could output at the same level, more or less, than the seasoned data professionals who didn't. So that's what I mean. It's sort of like,
Yes, yes, because of the productivity, because they were able to access this vast sea of experience, you know, knowledge that the ChatGPT is accessing with their language, you know, natural language system. When they go and look for you, yes, but however, there is a rule: conservation of energy. Okay, there's no something for nothing. So yes, they use the ChatGPT to present themselves better and almost show, but if you put them in a real life situation and they need to answer question without the ChatGPT beside them, then you see the difference.
Yeah, insofar as there's no power outage, though.
You see, a ChatGPT is a a good marketing tool, but beyond this, when you are boots on the ground and you have to perform and do your job, then experience is
Oh yeah,
is the law of energy. You know, there's no something from nothing. E equal MC square.
yeah. And
Always.
there is something to be said for the level of understanding that you have, right? So if if someone engages in code writing, they will and have been doing it for 10, 15, 20 years, their understanding and ability to problem solve that if necessary comes with a greater knowledge base so that they can go, oh, that is doing this, so I can maybe just apply it over here or make this slight alteration. Whereas, you can get the exact same code, right? ChatGPT can give you the exact same code as the data professional of 20 years wrote, but your understanding of it isn't as, it doesn't have the depth, so that you're like, all right, I know how to implement it. Do I know how to modify it? Do I know how to, troubleshoot it? I mean, ChatGPT knows how to troubleshoot that too, but you know what I mean? It's like,
Yeah, exactly. How you apply it in the real life. And this is where the gap come. Okay, so ChatGPT will not go and apply it for you in the real life. It will give you ad hoc answers, but not when you stand and solve the issues and has to defend it, you know.
yeah. And here's also what I'm going to say about data science, and I hope it applies to, or I hope it informs you as well, Javier. So right now, there might be, in the data science space, we have data scientists and machine learning engineers. And to some extent, those tasks and responsibilities overlap. But largely, the machine learning engineer is going to be aware of and build these sort of more nuanced, advanced models that rely on Gen AI or deep learning, and they'll know how to implement that as well, right, into production and to deploy that. Will we see now the data scientist now is needing to update the skill set such that they can now interact with, fine-tune, train these large language LLMs, large language models. So to that extent, like, how much more will they overlap in terms of these responses?
I tell you what happened is that those engineers, those the one that develop the models, okay, and everything, they have no clue. Most of them have no clue on the business, and some of them has a PhD even in mathematics, okay. So they come with the model, they come with the solution, and you look at this, it doesn't make sense, you know, completely. And then what people figured in the business that you have to sit with an SME, at least they will guide you where your model is going in the right or the wrong direction. And this coming back to the data science, he knows on the business because he understands the data. Okay, he might not have the same knowledge as the machine learning engineer, but in order to communicate is with him, because the level of the machine learning went up and up and up, he has also to improve his skills. Otherwise, there will be like this, you know, two parallel lines.
Yeah, and so the reason I actually bring this up is because I have been tracking job trends since August, and one of the hypotheses that I've had is you are going to see, so basically we scrape a jobs website and we extract companies, salary, position, experience, education, all this stuff, skills that are asked for by potential employers on this particular jobs website. And first of all, what I suspected was going to happen is happening, albeit slowly. So if we took a look at a breakdown of positions in the data science space, and we broke it down into 4 categories, if we broke it down to data analyst, data engineer, data scientist, and machine learning engineer, data analyst positions were always the most plentiful. Machine learning engineering positions were the least asked for, largely because maybe people didn't know how to leverage that position or why it was important. However, they are coming to understand the importance of the machine learning engineer in this generative AI moment that we have, because every given month has seen just a little bit more of an uptick and a little bit more of an uptick in the demand for machine learning engineers. So much so that it has now, and I started looking at the data in January. And by the way, there's a blog I write about this if you guys are interested.
Yeah, it's very interesting, because this is also related to the searches that you do in LinkedIn.
Yeah. But we're not scraping LinkedIn. LinkedIn is like notoriously difficult to scrape. But so now, in this month of January anyway, the machine learning engineering, which started off in August as the least demanded, has surpassed data engineering, and it's surpassed it for now 2 or 3 months, and is not quite at the demand of a data scientist, but not terribly far back. And then data analysts are now are still sort of the number one, but I suspect that number will drop to some extent. And further to that, what we are seeing, or what I am seeing, is when I'm looking at the skills, let's say the top 15, the top 20 skills required by each position, again, those 4: data scientist, analyst, engineer, and machine learning engineer. What you are seeing, or what I believe to be the case, or what I'm seeing, is that a lot of the responsibilities between the a lot of the skills between data scientists and machine learning engineers are overlapping. So you're seeing natural language processing skills being asked for both positions. You are now seeing, and you'll most definitely see, some aspect of large language model / Gen AI, generative AI, increase as well in both of those positions. And again, we've sort of been seeing that.
It's like it's like in anything that even you look to when they publish any job requirements, or requirements for a job as a project manager, they want this list, you get the laundry list, and this is almost the same. They coming with a laundry list because they're saying, I'm paying so much for this guy, so he might as well doing this and this and this for me, and also the real border, or the clear border between those two different type of proficiency is start to blurred. The overlapping is not clear. Segregation is not like, it's like overlap, like two circles overlap.
The two Zen
It's like this, the overlap, and they're coming closer and closer and closer. So let's say maybe a year or 2 or 3 years, the overlap maybe was 1%. Now maybe it's maybe 30% or 20%. According to what you say, maybe not like this, maybe 15%. Okay.
Yeah. So I mean, this is the interesting developments going forward. And by the way, Javier, where are you located? Steve, you're Toronto, right? Or
I'm Toronto. I'm in Toronto. Yeah. I'm in Toronto. Yeah.
New York, guys. I live in New York.
You live in New York.
Yeah.
Well, let me
I
tell
think
you,
we are not too far from each other anyway.
Exactly.
Well, I'll tell you this. Tracking the data science jobs from August, Toronto and New York are 1 and 2 in terms of the number of postings from this jobs website in any event. And Toronto has, in the last 3 months, overtaken New York actually as the largest data science jobs provider, according to this, as all qualified, but according to this particular site that we are scraping.
Okay.
And to some extent, New York had a little bit of a dip in the ensuing months before December, and now since December and in this month, because I just looked at the data today, it's on the uptick.
Jumping. There has been like a lot of layoff this year in many tech companies. So maybe, that has a little bit to do with the fact that New York maybe is decreasing a little bit in that way. Maybe the economy in Canada is stronger at the moment, probably.
Yeah, well, what's interesting too, right, is like in New York, obviously starts off with a greater population base, and one would think therefore a larger industry, more jobs, so that they would be, far and away leaders in terms of at least advertising positions for data science positions or in the data science space.
I think he's right. The fact that Google lay off so many people,
Right, 1,000, I think, like recently, like a few weeks ago.
Yeah.
Yeah, and there is let me try and remember the website that tracks the layoff, and it's crazy. It's been like more than 40,000 people that have been laid off so far this year in the tech industry in the States. Yeah.
Also in Canada is not the tech industry right now. The IT industry is really performing very poor. Maybe there's a pocket like data science or machine learning, and that's what I think. Those are maybe areas that are performing better, and actually your chance to have a job, even entry-level job, in data science or machine learning and this kind of stuff, it's higher than, for example, IT project manager or just a programmer.
Well, here I'll plug my blog, but if you go to the WeCloud.com, I'll take you through it, but just if you are interested. So we go to WeCloud.com. There's a thing called resources, and from resources,
This is your company, the WeCloud?
Yep.
So Beam Data WeCloud, they're sort of one and the same, the other side of the coin, basically. But I do based on the information that we scrape, I typically do a monthly blog, but you can find all kinds of blogs in terms of navigating the path to become a machine learning engineer, step-by-step guide. But this is, I think, the most recent one of mine. And just taking a look at how many jobs were scraped since we've been scraping them in August. You can see, the fluctuation on the number of jobs. I would caution you about reading too much into December being a drop-off. It's not typically a hiring month, and what we are finding is that if we had a poor December performance, January has more than made up for it. It's on par with August numbers. In August, I think, since we've been collecting the data, was the peak number of jobs provided. But yeah, you can see here the various positions broken down, all of which are following.
Yeah, I mean, especially because I think it's very time sensitive, or at least, it's moving really fast. The AI field, the past, I would say, maybe 14 months or so. That's very interesting, that data. I mean, you are keeping it, gathering and keeping it of data to see where the field is going, or where it's leaning towards to.
Yeah. And if you can see here, this is what I was talking about. If you see machine learning engineering, you can see just every month sort of ticking up. And this month, Anyway, I believe it's at 20 something, and this is against all of North America. And it's at 20 data scientists. It's sort of relatively unchanged. It goes in the space.
Right. It's kind of like unchanged, definitely. And guys, well, I mean, I'm not there yet, right? Because I am doing baby steps pretty much so far this year. But I have read that one of the main roadblocks to, ever enter and get a role in the AI kind of umbrella, it will be not having a portfolio or not having experience in the field and all of that. Well, as you were mentioning earlier in the meeting. So, I mean, what do you think for very beginner like me? What should I work on these early stages?
This is so I think you're right there, and I don't know when you jumped in tonight's presentations, but for me, the reason I actually chose WeCloud was because of the client projects. Two reasons. I chose WeCloud because I thought that the people there had a lot of, and I mean this, and I'm not by any means plugging them because I work with them. But for me, people who exhibit a great deal of integrity, it goes a long way with me, and it's valuable. And insofar as when I engaged with the people at WeCloud at the boot camp, I didn't feel like I was being processed or that they were telling me whatever it is that I wanted just to sign me up. And I thought I was dealing with honest and sincere players. I still think that, which is why I'm still with the company. But the other reason, and I think maybe even more so than that, was the real client projects, especially for myself, because again, I hadn't come from a STEM background, so I knew that I would have to leverage experience as opposed to sort of education. And I had so I took that opportunity and worked on the real client projects. And those were beneficial for so many reasons, one of which, of course, yeah, you get to leverage that on your resume and it'll get you into the door. And it has, I think an earlier question, which I didn't get around to answering, was what's the success rate, placement rate? When do you typically get a job? Our placement rate, and you can see it on an Ontario survey, is around 90%. I wish Adam was here. He has that link accessible, and you can see it on a government website. But it's about a 90% placement. And what typically happens is the graduates get jobs within in and around the 6 months. Some of them get a little early, depending on your background, depending on the education, all that stuff. But typically, graduates get the bulk of their jobs in about 6 months after graduating the boot camp, largely because in those 6 months they're working on the real client projects, and they are putting that down as resumes. And I know one of the students of the boot camp who I remember I was when I was still TA for that boot camp. She has since gotten actually a senior data analyst, or sorry, senior data science position, like right out of the boot camp. And it took her about maybe 4 months to do it. That's a senior position. So, and the extent to her background is, well, she didn't have any related to data science. So she really flourished in the boot camp, took advantage of the real client projects.
Is the prices is on the website? The cost of it?
I haven't seen the website. I wouldn't suspect it is.
It's a great question because I think that there is like a form that you have to fill out to maybe, I guess, receive the information or something like that. But maybe you guys can give us, a rough idea what it's like.
Yeah. So, for me, I paid around, what was it, 15,000, something to that effect. So ultimately, it's not cheap, but for me anyway, it's paid itself off. I secured a job, a career, and it was for me, it was a wise investment. But ultimately, it's you do want to think about where
Right.
you're. It's not chump change. It's a
No,
good.
it's not a jump change, and you know, it's also depend of if you are a self-learner or not, you know.
Yeah, yeah.
It's you know, I did all my education in programming and building systems and understanding from reading books, you know, and doing the exercises and spending a lot of hours.
Mhm.
It's not easy, but you know, it's like and they providing any payment plans, or you have to come
Yeah.
up.
Oh, yeah. Yeah. There's payment plans for sure. I just don't know what they are. I know the one of the things that I actually liked about and why I said they had integrity is I remember speaking with one of the coordinators, and I'm like, well, what's the placement like? What's the job placement? He goes, Alex, to be honest with you, it was really good before COVID. Right now, it's taken a dip because of it. And you know, I can't remember the numbers that he gave me, but I appreciated the fact that he was honest.
Honesty.
And I'm like, okay, you know, because everyone's like, oh yeah, this, that, and the other, and because I reached out to other boot camps, and I don't know, maybe
And sometimes you got the luck. You have to have the luck, you know, sometimes.
Yeah, that's also
But
true.
I will say this,
Lots of it, huh?
you you got to be good to be lucky, and lucky to be good.
Yeah, you know, you have to help. If you help to yourself, then you get help. You know, you have to help to yourself, and this is a part of it. You have to educate yourself. You have to learn. You have to get hands-on experience.
Yeah, I will say now you've just jogged a joke here from there's that old joke where, you know, every night this guy prays, please God, please let me win the lottery. Night after night after night, please God, let me win the lottery. Then finally God's like, you know, you got to buy a ticket, right? So it's like you got to, you know, help yourself by.
But the lottery is also the taxes that the stupid pay. So it's all depends how you look on it.
Yeah.
Because the probability to win the lottery is negative. Otherwise, they cannot make money.
Yeah. Wow.
So buy the ticket is only half the truth.
Yeah.
And half the truth is worse than a lie.
Yeah. Maybe, yeah. But
Looks from what you present here and from what your feedback that you project, I mean, they are pretty good company, pretty decent.
I think so. And again, honestly, I cannot overstate. Listen, you will be like the program does challenge you. It's not a Udemy course. It's not, you know, you are expected to push through this, absorb information, have an ability to apply it, and problem solve in some cases on the spot. But for me anyway, that was in some ways a challenge to the way I learned, because I like to like take my time. I like to go in depth, mull it over, and you know, nobody has time for that. but this program and the way it was structured, it sort of gradually ramps itself up, and then you have to hustle. You have to hustle, and the degree to which you hustle and be proactive and research and try and problem solve is the degree to which, for me anyway, that you want this. Because and then once you get it, that skill about adapting on the spot, learning quickly, being through the first project or the second project I was in, we didn't cover that in the boot camp, or only vaguely. The recommender systems we didn't. There's just so much that you can't go specific on so many things. But it's like, all right,
Is there some guidance there, or some you know,
absolutely,
a person that talk to you and you say, hey, listen, this is my background, what you recommend, how you do, and And if you do it as an evening course, like, you know, you go to work in the morning and at night, this takes
Yeah.
you 6 months or what?
Yeah, so there's two versions of the boot camp, right? There's the full time, which is 40 hours a week, basically 9 to 4, Monday to Friday. And then there's the part-time course, which there's a lecture, I think on Wednesday evening, and a lecture and a lab on the weekend. And it extends over 6 months because we understand that there are career changers or anybody who's just occupied with life that might that doesn't have the luxury of
So
devoting.
40 hour, it's what do you say the full time is again?
It's almost like it's like a 9 to 5 job. You know,
For how long?
For 13 weeks.
13 weeks.
14, like like 14, the 13th and 14th weeks are more dedicated to career advances and offboarding you and then transitioning you into the real client projects. But that's the great thing about it in terms of there is a level of understanding because
So for 14 weeks, you're talking 3 months.
yeah,
more.
3 months and a little bit.
Well, what I would say is like there is a small like pre-boot camp, which you don't if you don't have any knowledge on programming that helps you a lot. That takes around 2-3 weeks. But that is self-paced. So you
I know very well SQL Transact and Visual Basic, you know. So now I pick up my skills in Python. So
And then you also have an idea, guys, of what it's like, you know, those 40 hours per week. It's like live classes. It's just like assignment labs. I mean, what?
Yeah. There's the course material. There's the TA office hours so that you can, if you have any questions or you want to apply what it is that was learned in the lecture, those office hours are in the afternoon, and there's labs. Then
obviously it's give you a good base, and obviously you put on your resume that you have the certificate. It give you the big boost. I mean, there is benefits to it.
absolutely. I'm having the most wonderful time talking to you guys. I believe it or not, I have an appointment that was 4 minutes ago. I have to communicate with a client in a different time zone. So please find me on LinkedIn. Let's continue the conversation. Great talking to everybody. Thank you so much.
Thank you.
Ricardo and Steve.
Thank you very much. Thank you very much, Alex and Ricardo and Javier. Appreciate your time. It was a pleasure, and hopefully we can keep in touch.
Keep in touch. Find us on LinkedIn. Sorry,
Okay.
Ricardo, I don't know if you have to go. I think I'm host, so I have to end for everybody.
Yeah, that's fine.
Fine.
Okay, everybody. Have a good night.
Good night. Bye for now.